Hi dear friends, this is Shiva signing in Koluru Lectures. Today we are going to discuss about completing the squares method. So in the last video we have discussed about factorization. Now we are going to discuss about completing the squares method. Then when we have factorization method, then what is the reason behind to choose completing the squares method? So let us have an example for it. So now as far as the previous discussion with factorization method, let us try one more example. Let me write the heading. So now let us check what will be the values of x for x squared plus x plus 1 is equal to 0. Are we able to solve this with factorization method? Let us have a check for it. A value is 1, b value is 1, c value is also 1. So AC is 1, b value is 1. So now I have to select two factors such that product of two factors should be 1, and the same factors if I add I should get 1. Is it possible from a set of integers? No. So now this is the reason why we have to step into completing the squares method. Once again let me repeat. If I was unable to pick the factors from the set of integers, then I need to move on to the completing the squares method. Now what is the completing the squares method? So let us have a look on it. So let me take the normal equation, which is ax squared plus bx plus c is equal to 0. So here what I have to do is, let me take the coefficient of x square as well. So I will get it as x square plus b upon a multiplied with x plus c upon a is equal to 0. Let me send a to other side. So I will get it as x square plus b upon a multiplied with x plus c upon a is equal to 0. As we know here, it is completing the squares method. Means I need to complete a square here. So in what way? Suppose if I check here, this is a square term and this is 2ab term. So now what is b square? B square is nothing but, see, if 2ab term is, if this is a 2ab term, and if this is a square term, then what is b square? So simply if I have done half of it, half of the coefficient of x, automatically I will get the b square term. So now here if I have a check on it, so I can write this as x squared plus 2 into b upon 2a multiplied with x plus c upon a is equal to 0. If you observe here, this 2 will cancel again, I will get b upon a into x. So here I can, why we have written like this in the sense to check. See, this is a square plus 2, this is a term, this is a and this is b. So now I have a term which I need to be squared. So now let us do the next process for it. So now I have x squared plus b upon a x plus, see what here we are doing is, in order to complete the square, I am squaring b upon 2, b square term, and I am adding it and I am subtracting it. plus c upon a is equal to 0. If I see here, this three terms, I can write it as x plus b upon 2a whole square. This is the reason, see, when you compare the given heading, if you compare the given heading, completing squares method. So here I have completed the whole square. So now let me shift this entire term to other side. So b square upon 4a square minus c upon a. So x plus b upon 2a whole square is equal to, LCM might be 4a square, so b square minus 4ac. So x plus b upon 2a is equal to root over b square minus 4ac upon 4a square. Suppose if I take the value of x, I will get it as minus b upon 2a plus or minus root over b square minus 4ac upon 2a. So on common, if I have the same denominator, let me write as minus b plus or minus root over b square minus 4ac upon 2a. So that means I can get the value of x if I substitute the a value, b value, c value, the given term. Suppose let us check with that example also right now. I have the given example, which is nothing but x square plus x plus 1 is equal to 0. X square plus x plus 1 is equal to 0. Now let me get the a value as 1. We know b value is 1, and at the same time c value is also 1. So now what is the value of x? X is equal to minus b plus or minus root over b square minus 4 ac upon 2 a value is 1. So that means x is equal to minus 1 plus or minus root over minus 3 upon 2. So x is equal to minus 1 plus or minus root over minus 3 can be written as 3i square, where I square value will be is equal to 1. I square value will be is equal to minus 1. Sorry, I square value will be is equal to minus 1. So x is equal to minus 1 plus or minus root 3i upon 2. Here I can split these two values. So one value is minus 1 plus root 3i upon 2 minus 1 minus root 3i upon 2. So here the values which I got for x is not from set of integers. So this is the reason when I'm doing factorization method, I'm unable to think, I'm unable to track these factors. So that is the reason, in order to have a quick solution, so we are going for the completing the squares method. The same thing here, one more thing, the third method which I have discussed, which is Sridharachary's formula. It is nothing but this one, the direct form. X is equal to minus b plus or minus root over b square minus 4ac. So Sridharachary's rule can be obtained by completing the squares method itself. So this is about the methods which we are able to get the value of x. So now here, most conclusive step here it is, why we are going from factorization to completing the squares method. Because the reason behind it is, if we are unable to pick the factors, to select the factors from the set of integers, then it will be the right time to go for the completing the squares method. That's all for the day. Thank you so much, dears, and this is the right time to sign off from me. In the next video, we're going to discuss about the applications which are related to quadratic equations to control systems in a finest way and in an efficient way. Thank you so much. Have a nice day.